Okay, dear student, this video is for you to understand the meaning of per unit. So assume we have, the per unit, the per unit is for power system. In order to normalize the value, the formula is very simple. We must choose a base for our system, which, as I mentioned in the class, we have four important components in the power system, which are V, then S, then we have I, and finally we have Z. So the S covering P and Q, so no need to find the P base. This is for base, for the component which are important. And then the Z also covering the R and X. Okay, so in order to make the values normalize and in a small form to be more understandable, we're using this one. And other things, for the power system, the component of the power system is coming based on their local or their products base. Assume we have this transformer. I think by this example I can fully help you to understand the meaning of the per unit system. Assume I have a transformer here. Oh, sorry. Assume I have a transformer by here. This is why this one two is working for me. This is a transformer. Okay. This transformer is the S. The apparent power is given as 150 mega volt amp. Then the voltage for the sides are 230 to 132 kilovolt. So it's a step. Assume this is for this side, is a step down transformer. And the X reactance of the transformer refer to this value, this and this, okay? Refer to this value are given as a 0.3 per unit, okay? Then we are thinking to connect another transformer. We have another transformer in this way. Okay, the transformer is coming as S equal to 50 mega volt amp, and then the voltage again is 132 to over 33 kilovolt, and the X is in the form of only 0.1 per unit okay. Then the question is, uh, again, this X, the new X, this X is coming in the form of the is coming in the in the base of these two. So the base are these two. The question is, what is the real value of X? Are they exactly the same or different? So for this idea, we should find out step one, what is the per unit formula? The per unit formula is whatever is for any what do we call it, variable in power system. What is S, V, or X means Z, and I. Right now it is Z, so because it's X, Z per unit is equal Z actual over Z base. Z base. Correct? This is the formula for per unit. So if it is V, V per unit, V actual, V base. It is I per unit, I actual, I base. Okay, right now the question is, what is the Z base here? Okay, let me calculate the Z base for this one and then for this one. So Z base, based on the given value, the Z base can be calculated as this formula V2 over S. Then the V is the V, because both is considered for the side of 132. I choose the same 132. Okay, so the V is 132, 132K power of 2 over S, which is 50 mega. So this mega can be cancelled by the k power of 2. So 132 power of 2 over 50 equal, so I calculate here, let me check, over 50 is 348, 348.480. Then this is Z base for this part, for this transformer. I assume this is transformer B, this is transformer A. So this is Z base for transformer B. Okay. Then the value for the Z per unit, oh sorry, the value for the Z real or actual, what is this? Actual is coming in the way that Z base times Z per unit. So Z per unit is here, correct? This is the per unit value, and this is the base. The base is given by this one. So it's 0.1 times 348.48. So the final value is very clear, is a 34.848, correct? Oh, this is the actual value for transformer B. Let's jump to the part A, okay? Then here in the same way, what is the Z per unit, which is coming from this base value for the transformer? Means the company sell it based on something they have, okay, correct? Z per unit is, sorry, Z base. First we should seek the Z base. Z base for part A or transformer A is voltage, the same voltage I just put, 132, k power of 2. So I cancel right now the k by the m, which is 150 megawatt. The m also cancel. So the final value here is in form of 116.16. Oh, correct. Then the Z actual is equal, using this formula, Z actual is Z per unit, which is 0.3 times 116.16, which is equal, can you check? It is 34.848. Oh, so you can see whatever the transformer are different in the level and operation, the Z of the transformer in the what we call it, in the actual is the same, but in the per unit is different, correct? So because of that, we choose the new S base and new V base. So here V base chosen, new V base exactly the same as before. So I choose 132 because it's fully work for me. But the S base, I'm going to make it for 100 megavolt amp. So next step is to find out the Z base new. Z base new here is V base 132 over 100. 132 power of 2 over 100, which is 174, 174.24. 174.24. Oh, and then you can see the X per unit, the X per unit, the new X per unit new in the new form, which is coming for this one, okay, which is coming for this one, is 34.848 over 174.24. So the final value here is equal 0.2 per unit. Okay, so this idea and this formula on behalf of making first as actual value means find out this one as a base, real base for the component, and then actual value, and then convert it to this one can be easily done using this formula. The X per unit new is equal x per unit old times s base new s base old times v base old over v base new power of 2. Okay, let's check this one all together to see does it work for us or not. So in order to that one, x per unit new, okay, I just following this one first, okay, equal x per unit old 0.3 times s base new, which is 100, correct, over s base old, which is mentioned as 150, times v base new over v base old power of 2. V base new is 132. Oh, sorry, the same 132, 132. So here also 132. So this one is 1. You can see 0.3 times 100 divided by 150 is the same as per unit. So done. On behalf of doing many equations and many calculations, easily you can approach. For the other one, in the same way, x per unit new for the transformer. This is for transformer A. This is per unit. This is for transformer B is equal 0.1 times 100 over 50. So the voltage is again the same. So 132, 132. You can see is 132 here, the new, and the old also is 132 here, correct? So no need to assume just only one. I just put this one here. So become 2 times 100 over 50 is 2 times, so 0.2, again guarantee and correct. So you can see both answer easily can be calculated. So in the other way, for the other calculation, also you can using the per unit. The per unit maybe is a headache, maybe it's a headache for a small system such as this one. But when you use that one for the big system, for the power system analysis, when this one is a transmission line, another transmission line, generator, transmission line, everything here, it is very useful and will help you on the case of learning. So this is the way I can explain the per unit system for you. Thank you very much.